3 and 1000. That's a vector, belongs to R2. I can generate it from the principal two vectors, those two vectors. How? Very simple. I will multiply negative 3 times 1 and 0. Then plus 1000 in 0 and 1. Down the road, we will know that those are the canonical basis for this vector space. They are the main generators of this vector space. طيب مستر زياد، لو أنا بتكلم على vector in 3 dimension, can you give me a vector in 3 dimension?
1 و 5 و 7.
1 و 5 ومين؟
7.
وإيه؟
8.
8. 1, 5 and 8.
اه.
Can you find the generators or express it as a generators from the generators of R3? Yes. It can be FT
4.
1, 0 and 0 plus
1.
5 times 0, 1 and 0 plus 8 times 0,
0, 1.
0 and 1. So mainly, according to this, I can generate in a vector space. If I have the main generators, I can generate anything else belongs to this vector space. Let's talk about the vector space of the matrices 2 by 2. If I have a matrix 2 by 2, look at this game. Let's say 3, 4, Jana, negative 1 and 2. Look at this matrix. This matrix can be generated from the generators of the group of matrix which are 2 by 2. Very simple. Look at this game. 3 times 1, 0, 0 and 0 plus 4, 0, 1, double 0. Then plus, okay, I will continue عشان تبقى idea واضحة قدامك. Then plus
negative 1.
Yes, you are right.
0, 0, negative.
Okay, then plus negative 1, 0, 0, 1 and 0. Then plus 2 times 0, 0, okay, 0 and 1. So it's correct. Okay? So, remark, I'm going to talk in this part about the linear combination of vectors and the generation and the generated subspaces from this vector space. الناس لقيت ايه؟ بص اي vector space E, I can get another vectors in this E if I multiply the generators or any set of vectors at the linear combination according to this relation. ده اللي انا عملته. اهو this vector was 3 components. It was equal to some constant times a vector, some constant times a vector, and same way back. This bunch of vectors, Jana, I could succeed, or I succeeded in generating this V by multiplying alpha 1 times U1 plus alpha 2 times U2 and so on. This is the statement that you have here. Okay, this is really very important. Okay, I will read the slides. I think you could understand what I mean. Okay, let's read the slide step by step. Let E be a vector space over K. So I'm talking once more about real or complex. And U1 up to U are elements of E. From U1 up to U are any bunch of vectors in anyhow. They shouldn't, I'm not obliged to have the same number exactly. Maybe 2 vectors will do it. Maybe 3 vectors will do it. You understand what I'm saying? Okay, with the correct or with the suitable coefficients. So U1 up to U are elements of E. We say that V belongs to E, which a vector belongs to E, is a linear combination of the vectors U1, UR, if there are scalars, if there are alpha 1, alpha 2, alpha 3. Okay? Once you multiply them, you will have these vectors. So that's the condition for a linear combination. You have V, what you want to have, like this matrix. It's a bunch of vectors, belongs to the 2 by 2, multiplied by coefficients. So mainly I can generate infinite number of vectors belongs to any vector space just by multiplying numbers or coefficients in the generators or in any vectors in it. Okay, we denominate the scalars alpha 1 by the coefficients. That is very important. You may ask you all these coefficients down the road. The coefficients of the linear combination and the sequence alpha 1 up to alpha r by the sequence of coefficients. Because these coefficients will have to be in place by the same order to get a specific vector. Okay. So this is really a very important slide.
عندي سؤال.
Can it wait a little bit?
هو it's about this.
ايه؟
It's about
اوكي.
لو هي 3 4 3 2 بنعملها 3
تبقى
2
3 4 3 and 2.
يعني ما ينفعش نعمل one step for two numbers يعني ما ينفعش أول واحدة
ينفع.
1 0 1 0
1 0 ينفع.
one step على طول.
لذلك انا قلت لك ايه؟ هو الفيكتور سبيس ده كان بي جنريتد دي كانونيكال بيزس. اوكي؟ بس ينفع from any vectors with the suitable values of alpha 1 alpha 2 اللي هي السيكونس بتاع الكوفيشنتس. اوكي؟ طيب احنا هنروح بعيد ليه؟ تعالوا نبص على دي. أنا I have considered the vectors U and V يا فيصل. ال U triple 1 ال V 1 2 3 دول two vectors I think belongs to R3 صح؟
Yeah.
Okay. Of the vector space R3 بيقول if the vector -1 -4 -7 represent a linear combination of these vectors.
Let's see.
ينفع. هجرب مش عارف. طب اجرب ازاي؟ I will use the main formula. المين فورمولا بتقول ايه؟ بتقول ان الفيكتور اللي انت عايزه اللي انت عايز تجيبه اللي هو ال V should equal to let's say alpha 1 times the first vector which is
1.
plus the second vector which is this is alpha 2 the second coefficient I don't know which is simply
3.
you are discussing if the vector V is equal to -1, -4 and -7. Look at this formula. How many equations and how many unknowns? This means -1 will equal to alpha 1 plus alpha 2. And the -4 should equal to alpha 1, am I right? Plus 2 alpha 2. And also -7 should equal to alpha 1 plus 3 alpha 2. That's a system of equations. Can you solve it?
Yes.
شفت خدت matrices?
Huh?
And I will solve it for alpha 1 and alpha mean 2. So simply I can write the augmented matrix in seconds, which is 1, 1, then 1 and 2, then 1 and 3, and the results for this augmented matrix is -1, -4 and -7. Now I'm solving for the correct numbers of alpha 1 and alpha 2. Okay? طيب how to solve يا فيصل؟ How to solve this system؟ المفروض ان الكل دلوقتي بلايرز. ها؟ قول لي اعمل ايه؟ I can get the reduced echelon form. زياد انت بتعمل ايه؟
احنا دكتور كرينا بعت حاجه.
انت ما تعبان انت هنا شغال معايا. بص في السيلفون بتاعك ليه؟ Try to get the values of alpha 1 and alpha 2. How to get them؟ ها؟ reduced echelon form. ولا اروع يا زياد. طيب هضرب بقى الفيرست رو في -1 وادد on the second row. يلا.
يلا بينا.
ها؟
0 اكتب بس اول رو زي ما هو.
1 جدع 1 1 -1 -1 plus 1 is gonna equal to 0 -1 plus 2 is gonna be +1 negative times -1 +1 plus -4 is gonna be -3 once more for the last row -1 plus 1 is gonna be 0 -1 plus 3 is gonna be 2 negative times -1 is gonna be +1 plus -7 is gonna be -6 am I right؟ صح؟
Yes.
continue عشان اجيب reduced echelon 4. Mr. Mohab, next step تبقى ايه؟ Next step please. I will use the second pivot. مين is second pivot؟ ده. So I will leave the second row as it is, which is 0, 1, and the negative 3. Let's get the numbers blue and above equal to zeros. So I will multiply negative 2 and add on the second, on the last row. Negative 2 times 0 and 0. Negative 2 plus 2. Negative 2 times negative 6 is going to be 6. Plus negative 6, so it's going to be? Continue. I will multiply the second row, negative 1, and add it on the first row. Negative 1 plus 1 is 1. Negative 1 plus 1 is 0. Negative times negative 3 is positive 3. Plus negative 1, so it's going to be 2. So the values are alpha 1 will equal to 2. And alpha 2 will equal to negative 3. So the right combination will be, I will multiply the first vector in 2 in specific, and the second vector will be multiplied in negative 3. The result will be this guy. So actually, it's a linear combination of these two vectors.
If this wasn't true, this thing can be.
So it can't be a linear combination from these two vectors.
How are we gonna know?
It's very simple. This guy is gonna be zeros, and this is gonna be a number.
دكتور
Okay? خلي بالك من السؤال اللي سألته saying that's really very important. This one, it could be a linear combination. Sometimes it's not going to be a linear combination. So, يا زياد in the exam, ومس ندى, Miss فاتن, if you are asked to choose the correct answer, how is gonna ask you about this? He's gonna give you a statement. Let's say, number C, for a statement, for question. He will say to you, is the vectors 1, 1, and 1, or the vectors, will give it to you as a statement, the vectors 1, 1, 1, and 1, 2, 3 are linear combinations of negative 1, negative 4, and negative 7. Is it true or not? How to do it?
أحلها.
I will try to plot them here, try to find the values of alpha and alpha 2. If there is a solution, then it is a linear combination. If I'm trying to solve, then this number wasn't negative 6, it is positive 6. So at this step, you will find 12 in here. So there is no solution for the system, which means there is no values for alpha 1, alpha 2 that will make these this vector a linear combination from these two vectors. You understand what I'm saying? So this is going to be a wrong statement. You don't choose it.
But how do we know that it's just a combination of two? And why can it be alpha 1 multiplied by the first one, alpha 2 multiplied by the second one, and alpha 3 multiplied by the second one?
It can be.
How?
Okay. How you know? It's exactly the same. Instead of having two vectors, you will have three vectors. Okay? And then instead of dealing with a system, three equations and two unknowns, you will be dealing with a system of three equations and three unknowns, and so on. You read what I'm saying?
Yes, but how am I going to decide if this needs?
Exactly the same. You will solve the system, but instead of three equations and two unknowns, it is going to be three equations and three unknowns. And now the solution will be in how many values? 1, 2, and 3. And now we are talking, we are away from the vector spaces. We are in the cases related to a solution of a system of equation. You may have one solution, you may have infinite number of solutions, or may have no solution. No solution, it means it can't be a linear combination. then you will have either a unique solution, which is this one, or infinitely many number of solutions that will show you a problem just in a second in this case. Okay? Okay.
يعني مش دي كده infinity number of solutions.
ازاي؟
دي
انت عندك equation زياده. الصف الاخير ده كله ده بزيرو. Okay? It's a redundant equation. Actually, you have two equations in how many variables?
2.
So alpha 1 is 2, alpha 2 is negative 3. The last equation didn't add anything. It's a redundant equation. If you took ranks for this system, the rank of the younger matrix is 2. The rank of the augmented is 2. And the number of variables is 2, alpha 1 and alpha 2. So it's a unique solution. ده بيسموه over determinant system. يعني system فيه عدد من الايكويشنز اكتر من الانونز. فيبقى still 3 possibilities already can happen.
هو القانون ده اللي هو ايه؟
القانون اللي هو الفا 1 والفا 2. اوكي؟
الارقام اللي هو نيجاتيف 1 نيجاتيف 1
دي الانونز الفا 1 والفا 2. ده السيستم اللي انت بتحله. مين اللي انت مش عارفهم؟ ماشي؟ طبعا اهم 2 ونيجاتيف 3 they will get you the vector that you want to have. Okay, the vector negative 1, negative 4, negative 7 is a linear combination of the vectors u and v. Okay, تعالوا بص على السيستم ده. Consider the matrices A and B. عندك how many matrices? A and B. A 1, 2, 3, 4. B negative 1, 5 and 3. Get a new matrix. هات لي matrix جديدة. With a linear combination. Using the coefficients of the linear combinations 2 and negative 3. What's gonna be the new matrix? ندى فاتن. New matrix يبقى شكلها عامل ازاي؟ I will multiply 2 in the first and the negative 3 in the second, and I will get a new generated matrix which is a linear combination from these two. يبقى هنا انت شفت ازاي اجيب الكوفيشنتس اللي تعمل لك linear combination. هنا I can generate, and I'm generating a new vector based on the sequence of the coefficients 2 negative 3. خدت ده ضربته في 2 خدت ده ضربته في negative 3. Just a second please. For these two vectors, can you get a new vector with the coefficient 7 and 5? This is very, very simple. I will multiply the first vector in 7, I will multiply the second vector in 5 and add them together. Okay? Done.
ماينس في النص
Okay.
صح؟
ايه؟
ماينس المالتيبيكيشن صح؟
مش فاهم شوية.
دي ماينس دي محطوطة ليه؟
لأن هو بيقول لك 2 ونيجاتيف 3. اوكي؟ طيب خلي بالك بقى، خلي بالك في الاكزامبل ده. بيقول 0 is a linear combination of any vector. طبعا الفيكتور النل هو يعتبر linear combination from any set of vectors ل any number of vectors. لأن في الحالة دي هيبقى ال sequence of coefficients equal to 0. So in null is very, very simple. Just put the coefficients equal to zeros. And you will have 0 times u1, 0 times u2, 0 times ur. If I want to get the null as a generation from these two matrices, I will multiply the first in 0 and the last in the 0. Then I will have the null vector relative to the vector space E. Whatever the vector space representing what? Matrices, polynomials, vectors, 2-dimension, 3-dimension, whatever. You understand what I'm saying? So I want you to free your mind. We are making examples on vectors, but it's the same way like applying it on matrices. Same way like multiplying it on polynomials and so on. Okay, look to this one also. Any vector of R3, we already saw that. Any vector of R3, we already saw that. Okay, is a linear combination of the canonical form. This is called the canonical form, the basis. We will get it down the road. Which are 1, 0, 0, 0, 1, 0, 0, 0, 1. Any vector, ABC, can be simply A times 1, 0, 0, B times 0, 1, 0, C times 0, 0, 1. So these vectors are linear, or this vector is a linear combination from the canonical form. Also, we can extend it to En. En, it means if you have an n-dimension vector space. Because I can have vectors in 2 dimensions, which contains 2 components, زي 2 1. I can have vectors in 3 dimensions, like 3, 4, and 5. I can have vectors in 4 dimensions. I will have 4 components. And I can have vectors in n dimension, which will contain n components, same way like generalization. And if I have a vector in n dimension, it can be a linear combination from the canonical of this n dimension. So if I'm talking about 5 by 5, a vector in 5 by 5, let's say 1, 2, 3, 4, and 5. Okay, these are the coordinates. I will multiply 1 in 1 and 4 zeros. Then 2 in 0, 1, double 0. Then 3 in 0, 0, 1, and 0. And so on. Okay, this is the statement here. So, more generally, any vector of Kn is a linear combination of the vectors E1 up to En, which are the linear combinations. That's the general form. That's what I'm telling you about. About E1, E2, blah, 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 up till you reach En. Okay, in R2, let's look to this problem. In R2, the vector 3 and 3 is a linear combination of the vectors 1, 1 and 2, 2. Okay? The coefficient of the linear combination are not unique. They يديلك infinite number of solutions. تعال نشوف كده. Can you get the coefficients? Can you get the coefficients? Okay? That will make the vector 3 by 3 a linear combination from the 2 vectors 1, 1 and 2, 2? I can. So 3 and 3 should be a linear combination from which vectors? Alpha 1 times plus alpha 2 times, okay, which is a system of how many equations and how many unknowns? 2 by 2. اهو هكتبهم على طول الاوجمنتد ماتريكس. It's gonna be 1, 2, 1, 2, and it's equal to 3 by 3. That's a system of 2 equations and 2 unknowns. Try to solve. Try to solve. It's gonna be 1, 2, 3, and the results will be, which means for any set alpha 1 plus 2 alpha 2 equal to 3, which means alpha 1 should equal to 3 minus 2 alpha 2. This is a general solution. That's a general form of the solutions that will force these two to work together for the values of alpha 1 and alpha 2. So the set of solution will be alpha 1, 3 minus 2 alpha 2 and the alpha 2. That's the set of solution. That's the first coefficient and that's the second coefficient. Okay? And you will have infinite number of solutions. معايا يا جنى؟ ما هو ده infinite number of solutions. The rank of the coefficient matrix is 1. Rank of the augmented matrix is 1. And the number of variables, so you have infinite number of solutions. It's already exists. If you put alpha 2 by 1, if we consider alpha 2, 1, so it's gonna be 1 and 1. This is alpha 1 and that's alpha 2. Those two numbers, if you add them, 1 times 1, 1, okay, 1 times 2, 2, add them together, it's gonna be 3 by 3. Okay, let's try to get something strange. I will use alpha 2 equal to 0. If you put alpha 2 equal to 0. So alpha 1 will be, this is alpha 1, this is alpha 2. Take these two values. Try to multiply them here. The result will be, okay, once more. Okay, let's put alpha 2 equal to negative 2. If I inserted alpha 2 by negative 2, then it's going to be 3. Then minus 2 times negative 2 is going to be positive 4. So it's going to be, take these two numbers and multiply them. 7 times 1 by 1 plus negative 2 times 2 by 2. The result will be 3 by 3. So I have infinite number of solutions. So that's the first solution, that's the second, that's the third. By the idea, it's just only luck. So the general solution is alpha 1 plus 2 alpha 2 equal to 3 as I show you. Okay?
هو ليه خلينا زيرو الصف الثاني؟
بحاول اوصل reduce the echelon form. This is the main matrix. Try to get to reduce the echelon form. So beneath the 1 you should have 0. So I will multiply the first row by negative 1 and add it on the second row. And there will be a surprise that all the elements are zeros. حلو صح؟ بلاش تاني. واضحة؟ Okay. So let E be a vector space of U1 up to UR. Elements of E, the set of linear combination, خلي بالك بقى. The set of linear combinations of the vector U1 up to UR. That's the set. خلي بالك. Alpha 1 U1, alpha 2 U2, blah blah blah, up to alpha R times UR, such that alpha 1, alpha 2, alpha up to R belongs to K. They are numbers. صح؟ Okay? Is a subspace of E الست بتاعت الفيكتورز دي تعتبر sub vector space from مين؟ From E. Okay? Those set of linear combinations. Okay, هنا ده بروف. خلاص سيبك من البروف. وطبعا عشان اعمل بروف وريتك انه الاديشن will be the same, انه المالتيبيكيشن by scalar will be the same. So I will skip. Okay, now we know that we have the basis. I will stop by this slide right here, but I will read it first. Mr. Ziad, let U1 up to UR be elements of vector space E. We denominate subspace of E generated. I can generate. Those are generators at the time being. Okay? By the sequence U1, UR, or by the vectors U1 up to UR, this subspace is denoted by this special shape of R's. Those are the generators of this vector space. That's U1 up to UR. It will generate the vectors in this vector space. How they are going to generate it? Multiply alpha 1 U1 plus alpha 2 U2 plus alpha 3 U3, whatever the numbers. Then you will have vectors belongs to this vector space. And they are called, we say that U1 up to UR, اسمه generate F. Or that U1, UR are generators of F. It's like exactly 1 and 0, 0 and 1 are generators of R2, or 1 double 0, 0 1 0, 0 0 1, which are generators of R3 and so on. Okay? As I told you, I will stop by this slide and then we'll continue next time, inshallah. He is talking here about the example that we already did go through it. The main generators of R3, which is the canonical. This is the standard before, okay? And we will show in the next lectures, because this is the last lecture for this week. I'm not going to see you until the next week. Thursday, it's a vacation, a public vacation, because of the 6th of October. Wish you all the best. Today is a vacation. Should be a vacation, but we already will have it on Thursday. So those are examples of the basis, but I will stop. Okay. Thank you.